All right. Well, we've been talking about functions and graphs of functions. And we've looked at set notation and interval notation and domain and range and what may have to be excluded from domain and range. We've taken a peek at some of those things. Those things we're going to be doing over and over and over again. Now, we've talked about some other things that will come up occasionally. We'll take a peek at, such as symmetry, and then what we did in the last chapter section, continuity in behavior, and even to a lesser extent, limits. And in this chapter section, we're going to continue by looking at extrema and average rates of change. So let's just do a little introduction here of what this chapter section is going to be all about. All right, so let's look at a quick introduction to extrema, which I think is a Latin word. In fact, when I type it into Word, it shows up as misspelled. But anyway, we'll move. Graphs, they provide us a quick way to understand the relationship between variables. And one of those things that it helps us do is find maxima and minima, both relative and absolute. And this is where the points on a graph, where the relationship between the variables change from increasing to decreasing or from decreasing to increasing. And so as we see the graph move, let's say we got something like this. Oh, let's get it in a different color. Where maybe we got something like this, and we're seeing a change here. Here we've been increasing and to this point right here, and then we go decreasing to this point, and then we come back up here, increasing again, and it looks like we're getting ready to take a dip after there. Maxima and minima, that is both relative and absolute. Points where where we go from increasing to decreasing or decreasing to increasing. And the other thing that we're going to look at in this chapter section is the average rate of change. And so the average rate of change between any 2 points on the graph is its slope. And you're familiar with slope, I'm sure, when we were working with linear functions. And the principle is the same. We got to do a little bit more calculating or reviewing the tables on our graph, maybe more on our graphing calculator more particularly, in order to determine these. And so, you know, when you had a linear equation, well, you knew what slope was. I mean, slope was rise over run. And we may have defined that as the change in y over the change in x. And then maybe more particularly, you may remember we got y2 minus y1 over x2 minus x1 when we have two sets of ordered pairs. And this would be how we would calculate this on a linear function. And the principle is still the same. However, when we're dealing with a quadratic or a cubic or some other type of function other than just a linear function, we're going to have to calculate what these y values are. And, well, that's what we'll do. And you'll see. And it'll be fun.